Hello, I'm Youngbom Kim from Dongguk University DTM Lab. Today I'm going to review a paper titled Examining Product Quality and Competitiveness via Online Reviews, an integrated approach of importance, performance, competitor analysis, and Kano model. This is the bibliographic information of the paper. The paper introduces Kwak, which stands for Kano-weighted importance, performance, competitor analysis. The authors aim to provide a systematic and quantitative way to measure product quality and competitive positioning using online reviews. By combining sentiment analysis, logistic regression, Kano classification, and competitor benchmarking, the paper delivers a framework that better reflects true market perceptions and suggests clearer strategies for improvement. Here are the contents of the review. This is the introduction of the paper. The authors explain that online customer reviews provide real-time feedback for product and service improvement, allowing data-driven decisions without costly survey. They stress the need for competitor benchmarking since markets are highly competitive and require comparing performance across brands. Traditional IPA often ignores positive negative sentiment asymmetry and competitor distribution, which can lead to wrong priorities. The purpose of this study is to develop the Kwak framework, combine IPCA with the Kano model and visualize competitive positioning to support improvement strategies. This slide reviews previous studies on review-based Kano analysis. Traditional IPA surveys are costly and time-consuming, so researchers turn to review-based IPA as an efficient alternative. This approach uses sentiment analysis of online reviews to measure both attributes importance and performance. Importance can be measured by appearance frequency or by statistical significance using regression and machine learning models. Performance is often measured using sentiment scores, positive review ratios, or star ratings. Recent works also combine topic modeling techniques like LDA or bar topic with machine learning to build dynamic IPA models and enable continuous quality monitoring. On the right, Table 1 summarizes the key studies comparing IPA and Kano analysis across different domains such as hotel services, smartphones, and tourism. This slide continues with review-based Kano analysis and the integration with IPA. The Kano model classifies attributes into attractive, one-dimensional, must-be, indifferent, and reverse types, which helps explain their effect on satisfaction or dissatisfaction. However, survey-based Kano can be expensive, so recent studies use sentiment data combined with conjoint analysis to make it more scalable. Machine learning approaches have also been proposed, including ordered choice models, rule-based methods, and logistic regression, as well as hybrid ML pipelines with LDA, SVM, and neural networks. There are also extensions like Kano analysis and Kano QFD frameworks for more comprehensive evaluation. In section 2.3, the authors explain how they integrate IPA with the Kano model. IPA identifies high importance but low performance attributes, while the Kano model tailors strategies based on attribute type. Previous studies often combine IPA and Kano but focused only on the importance dimension, leaving performance unadjusted. This study fills that gap by introducing Kano-weighted performance and benchmarking across competitors, forming the basis for the Kwak framework. This slide introduces the method section. First, in step 3.1, the authors prepare the review data and perform attribute level sentiment analysis. The input includes online text reviews, star ratings, and timestamps. The task is to extract key attributes from each review and assign positive or negative sentiment. They use either lexicon-based methods or AI classifiers to tag the sentiment for each attribute. This step produces a dataset where each review indicates whether an attribute was mentioned positively or negatively. Moving to step 3.2, they assesses how sentiment impacts satisfaction. The goal is to estimate how positive or negative mentions of attributes affect whether a customer is satisfied or not. They use binary logistic regression with attributes level sentiment indicators and hotel-specific bias terms. Key outputs include beta plus and beta minus coefficients, which show how praise or complaints shift the probability of satisfaction. The hotel bias firm adjusts for differences in baseline satisfaction across hotels. After testing, the model with hotel bias showed a better fit and was selected for the following steps in the analysis. Next, step 3.3 explains how the authors identify attribute importance and assign Kano types. The importance of each attribute is calculated by comparing how strongly positive mentions increase satisfaction versus how strongly negative mentions decrease it. Simply put, the bigger the gap, the more important the attribute is considered. Then they perform Kano classification, which use the direction and size of these effects to classify attributes into 5 categories: indifferent, reverse, one-dimensional, attractive, and must be. They also add two types, OA and OM, to show whether existing expectations or reducing complaints is more critical for each attribute. The figure on the right shows this rule-based classification process visually. Step 3.4 evaluates Kano-weighted performance. The goal here is to measure performance by accounting for how strongly positive and negative mentions affect satisfaction. The authors combine positive and negative mention rates and weight them by their impact from step 2. Then they normalize the score against the market average to see which hotels perform above or below market level. This approach reveals gap hidden by simple counts. For example, a hotel might have many positive mentions but still perform poorly once negative mentions were weighted. Finally, step 3.5 introduces the Kwak matrix formation. This matrix plots attribute importance on the x-axis and Kano-weighted performance on the y-axis. Each column shows a box plot of market performance with an average line, so we can easily compare where our product stands relative to competitors. The interpretation is straightforward and uses 4 quadrants. Quadrant 1 shows attributes that perform well but less important, meaning we should avoid overinvestment. Quadrant 2 represents high priority strengths. These should be maintained because they contribute strongly to satisfaction. Quadrant 3 indicates critical weaknesses, which should be the first targets for improvement. Quadrant 4 highlights low priority issues. This can be monitored but do not require immediate action. As you can see in figure 3 on the right, this visualization provides a clear and intuitive way to prioritize actions by combining importance, performance, and competitor benchmarking. This is the first step of the empirical study: review data, preparation, and attribute level sentiment analysis. This study used 8,567 reviews from 22 five-star hotels in Seoul. The reviews were analyzed for 7 attributes: room condition, service and staff, facilities and convenience, location and surroundings, dining and food, bathroom, and furniture and appliances. For sentiment tagging, the authors applied the KNU Korean Sentiment Lexicon with 130 positive and 121 negative words. Each attribute mentioned was classified as positive or negative, achieving about 86% accuracy. The result is a binary dataset showing whether each attribute was mentioned positively or negatively in each review. This is the second step, assessing sentiment impact on satisfaction. Binary logistic regression was applied to reviews from hotels. Model 2 with hotel-specific biases outperformed Model 1 and was selected for further analysis. All attributes except location and surroundings were significant with no multicollinearity detected. This is the third step, modeling attribute importance and Kano analysis. Service and step was the most important attribute, so service improvements should be prioritized. All attributes were one-dimensional with SS, RC, FA, PC focusing on reducing complaints, and DF, FC focusing on exceeding expectations. This slide shows the Kwak metrics comparing importance and performance. As you can see, service and step and room condition are the most important attributes. Hotel 9 performs very well on both, so the recommendation is to keep the current service quality and consider small upgrades for furniture and appliances. Hotel 20, on the other hand, has very low scores for service and staff. This means staff retraining should be the top priority, while other attributes are close to the market average and can simply be monitored. This slide is the discussion. First, we compared Kwak with two benchmarks, the traditional IPA and approved IPA. We found that these benchmarks often put attributes in different quadrants, which can lead to conflicting strategies. Traditional RPA ignores negative feedback and is biased by attribute frequency, while Kwak gives more reliable results by combining sentiment, Kano types, and competitor data. In terms of limitations and future work, Kwak better reflects market perception by balancing positive and negative mentions. It also provides consistent and actionable strategies. For example, Hotel 20 must focus on staff training, while Hotel 9 could work on improving dining. Overall, Kwak offers a more reliable tool for competitive benchmarking and decision making. This slide is the conclusion. The study proposed the Kwak framework combining IPA and the Kano model for a more robust review-based quality analysis. It visualizes attribute importance against competitor adjusted performance and balances positive and negative sentiment to guide improvements. The case study used 8,567 reviews from 22 five-star hotels in Seoul and identified key strengths, weaknesses, and priorities. Limitations include focusing only on hotels in the one region. Future work will apply Kwak to other industries with use advanced ML sentiment analysis and segment reviews by demographics for deeper insights. Thank you for listening my review.